Hello, my name is Alex Albaugh. I am currently a senior in the Chemical Engineering Department at the University of Michigan. This summer, I have been doing research for Professor Ronald Larson through the Shear program. The purpose of my work is to use computer simulations to investigate the stretching and tumbling behavior of semi-flexible polymers when subject to a range of shear flows. I have been working directly with graduate student Indranil Saha Dalal. His work is similar to mine, but deals with flexible polymers such as polystyrene, whereas my research is with semi-flexible polymers such as DNA. Here we see a visualization of one of my computer simulations. The model used to represent a semi-flexible polymer is a bead spring model. Segments of the polymer are represented by beads and are connected by invisible springs. Bending potentials are also placed between the beads to mimic the bending behavior of semi-flexible polymers. In this visualization, there is a shear flow in the horizontal direction and a velocity gradient in the vertical direction. We cannot see the advection of the polymer because the camera is following its center of mass, but this allows us to observe the conformations quite well. The small high-frequency fluctuations you can see are a result of Brownian motion, the random thermal collisions with the solvent. As you can see, the polymer never reaches a steady-state configuration. It undergoes a series of stretching events followed by tumbles back into a more compact form. This behavior is typical of a polymer in shear flow. We can quantify the amount of stretch of the polymer by time averaging the polymer's length in the flow direction and using quantities defined in polymer physics, such as the radius of gyration, abbreviated Rg. Indranil Dalal showed that the stretch of a flexible polymer counterintuitively decreases with increasing shear rate at very high shear rates, as seen by this graph of his data. This behavior had previously not been well characterized. My work has begun to show that semi-flexible polymers also exhibit this non-monotonic behavior, although the onset of the decrease in stretch is delayed to much higher shear rates than that of flexible polymers. Investigation into the causes of this are still ongoing. I would like to thank the following departments and programs at the University of Michigan for supporting my research. If you have any questions about my work, please feel free to email me at this address. Thank you for taking the time to watch my video, and go blue!